To build a machine that perfectly understands reality, you first have to teach it how to deceive itself. Most artificial intelligence relies on supervised machine learning. You feed the model millions of examples of historical data, neatly labeled with the correct answers, and it learns to predict what comes next. But if you're trying to detect a rare financial fraud or anticipate a highly specific autonomous driving crash, that historical data doesn't exist. You can't train a model to catch a black swan event if you don't have thousands of black swans to show it. This scarcity problem is why engineers developed Generative Adversarial Networks, or GANs. Instead of relying on humans to curate massive datasets, a GAN supervises itself. When human-labeled data runs out, the only way to push the boundaries of machine intelligence is to force the algorithm to compete against itself. A GAN is actually two separate neural networks locked in a battle. The first is the generator. Its only job is to take a field of pure random noise and try to synthesize fake data. The second network is the discriminator. It acts as a judge, taking the generator's fake output and comparing it against a database of authentic, real-world examples to spot the forgery. This creates a mathematical zero-sum game. The model that wins the evaluation remains entirely unchanged. The model that loses is forced to update its neural weights. Over millions of cycles, this tension escalates. The generator learns to forge flawlessly, which forces the discriminator to look for microscopic anomalies, which forces the generator to get even better. This relentless adversarial tension essentially forces an evolutionary leap inside the machine, generating flawless data without requiring a single human to label it. This process bridges what roboticists call the sim-to-real gap. By synthesizing high-fidelity training data, hospitals can generate highly detailed anatomical scans to train diagnostic tools, entirely bypassing the privacy risks of using real patient data. In physical AI, these networks can take a single frame of surveillance video and predict the immediate physical future of that environment, plotting out exactly what happens in the next sequence. They can also ingest low-resolution sensory inputs, like a blurry camera feed in a manufacturing plant, and enhance it pixel by pixel into clear, actionable intelligence. The logic even extends beyond images. By pitting a generator against a discriminator in cybersecurity, we can forge highly secure encryption algorithms that constantly adapt to deflect attacks from simulated decryptors. These adversarial networks unlock a significant capacity to synthesize reality, but they also create a volatile landscape of artificial information. For global enterprises, this makes it essential to maintain rigorous security and infrastructure control over every generated output. Deploying generative models on public clouds creates massive enterprise vulnerability. Sending sensitive information to external APIs exposes data to exfiltration. Treecapital's Anven AI provides a structural solution, an enterprise framework designed to execute sophisticated models entirely behind air-gapped corporate firewalls. This establishes absolute data sovereignty. The model weights, the inference engine, and the security protocols exist exclusively on your own on-premise servers. Because this localized deployment guarantees zero external network calls, highly regulated fields like finance and healthcare can run advanced AI without violating strict compliance mandates. This transforms AI from a rented utility into a secure digital asset living on your own hardware. Anven 1.1 introduces late fusion multimodal processing. Rather than treating images and text separately, this architecture processes both visual tokens and linguistic text simultaneously within a single shared vector space. This unified processing allows the model to see and read at the same time, enabling accurate document auditing and complex circuit defect analysis where visual context is inseparable from text. To guarantee factual accuracy, Anven utilizes RAG-native grounding. Before the model generates an answer, it is forced to check your internal corporate databases. If the data doesn't exist, it reports the absence, effectively eliminating hallucinations. This secure reasoning isn't confined to a server room. Using optimized, quantized 3 billion parameter models, Anven pushes these operations to mobile and embedded devices at the physical edge, ensuring near-zero latency. As AI synthesizes reality at scale, the most resilient enterprises will use sovereign frameworks to detect, manage, and deploy their intelligence independently.